So, second mastery pack test. Good luck, hope it went well. This is, in case you don't know, the Master of Disguise. And soon you will be the Master of D1. Okay, so Dijkstra. We're going to start at A. So far we have travelled a distance of nothing. We could go along here, that would be 12. We could go along here, that would be 10. Sorry, the boxes are a bit too small. We could go along here, that would be 15. So the smallest working value we have is 10, which is here. So we go to C second, and final working value is 10. From here we update. So we get a 22 here. We get 14 down here, which is smaller than 15, hooray. And we get 15 up here, which is not smaller than 12, so don't bother writing it down. Smallest working value now, 12. So we go here next, and then we update. So 12 add 3, that's 15. 12 add 6 is 18, which is smaller than 22, that's the end. Smallest working value, 14, so we go therefore, that's 14. Nothing to update from that point, done. So next smallest working value is at F, so that's 5, 15. Update from there, 15 add 2 is 17, which is smaller than 18, hooray. 15 add 3, 18, 15 add 9 is 24, and that's all the updating done. So next smallest that we have is 17, so we go here 6, this is 17, we update from here. 17 add 3 is 20. Next smallest that we have is 18 up the top, so we go there next, that's 18, we update from there. 18 add 5 is 23, which is less than 24, hooray. Next smallest is 20, so we go here 8th, and the final working value is 20. 20 add 2 is 22, which is smaller than 23, hooray. So next is here 9, 22 final working value. So quick check, how many boxes were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and I've got a 9 there as my final, whatever that's called, order. So that's good, hooray. So the length, the shortest length is 22. Now what about the root? So starting from the 22, 22 minus 2 is 20. So that means that I've got 22 minus 2 is 20. So that means I need to do IH. And then 20 minus 3 is 17. 20 minus 3 is 17. So that's this bit here, which is HE. And then 17 minus 2 is 15. So that's this 17 minus this 2 is this 15. So that's, what is that? EF. And then 15 minus 3 is 12. So that's this 15 minus this 3 is 12. So that's F to B. And then 12 minus 12 is 0, which is obviously this 12 minus this 12 is this 0. Down here, B to A. So the root is, you can see it here, is A, B, F, E, H, I. That's the shortest root. Right, definitions. You obviously have until the exam to learn these, but a bipartite graph is a graph, no surprises there. It has two distinct sets of nodes, and there are arcs, and the arcs connect nodes from different sets. Arcs must not connect the nodes within a set. Sorry about my rubbish writing. Okay, a matching is a one-to-one pairing, that's important, that it's one-to-one, of some or all, it doesn't have to be all of them, some or all of the elements of one set of a bipartite graph with elements of the other set. Okay, complete matching. complete matching is when both sets of a bipartite graph have n nodes, well basically they're the same size, and you have a matching, and the matching has the same number of arcs as there are elements in each set, and the matching has n arcs. You do need to learn these. It is worth about a grade, these definitions. Okay, matchings now. So, the situation looks like this. I think I'll draw it down here and then move it. So we've got Alan, and we've got Jeff, and we've got Laura, and I think we've got Nicola, and we've got Philip, and we've got Sam. And we've got some checkpoints for them to go to. 2 people can go to 1, so we'll call them 1A and 1B, and then 1 person on the others. So we've got, who's this? Alan. Alan can go to 1, that's going to 1, or 3. And Jeff is happy on 1, but he is also happy on 5. And Laura could also go to 1, that's fine, or 2. Or in fact, I think Laura's actually quite helpful, she'll go to 4 as well. And Nicola will only do 5, she's fussy. And Philip can do 2 or 5. And who's this at the end? Whoever this is. Sam. Sam can only do 2. So this is our possible situation that we can use, all the possible pairings. The initial pairing looks like this. Alan on 1, Jeff on 1, Laura on 2, and Nicola on 5. And what we need to do is come up with an improved matching for this situation. So there are 2 ways of doing this that I found when I was playing around. So first of all, I started on Philip, and I said, well, Philip is not attached to 2. And then, why didn't I go to 4, 5? Oh yeah, you can't go to 5, because if you go Philip isn't attached to 5, which is attached to Nicola, then you're stuck, because Nicola won't do anything but 5, so that's no good. So we have to go from Philip over to 2. So Philip isn't doing 2, but 2 is currently connected to Linda, or whoever that is, Laura, and but Laura could do 4, and that's fine, no one's on 4. So we've got a connection between Philip and 4. So then we change the status. We say, Philip, you're going to do 2. Linda, Laura, you're not doing 2 anymore. You're going to do 4. So the improved matching is as follows. Alan is still on 1A. Jeff is still on 1B. Laura is now on 4. Nicola is still on 5. And Philip is now on 2. So that's one way that I did it. See if I can, no. Maybe, no, didn't mean that. I meant this. Okay, so the other way that I thought to do it, which you might have done, is to again start with Philip and again go to 2 because you have to, which is connected to Linda. Laura, why do I keep calling her Linda? But anyway, then instead of putting her on 4, put her on 1A, because she's happy to go on to 1A. 1A is currently connected to Alan, but Alan could do 3. So that's another alternating path which gets you from the left-hand side on an unmatched node to the right-hand side on an unmatched node. It's just a different unmatched node. So changing the status, we put Philip on 2. We'd say, Laura, you're not doing 2 anymore, you're going to do 1A. So Alan, you're not doing 1A anymore, you're going to do 3. So in that case, the improved matching would be Alan now on 3, Jeff still on 1B, Laura now on 1A, Nicola on 5, and Philip on 2. Both of those are fine. Okay, now it says, why is a complete matching not possible? So if you have a look at the original situation and the way that it could be matched, if you have a look at Nicola, Philip and Sam, these 3, then Nicola wants to do 5, Philip will do 2 or 5, Sam will only do 2. So between Nicola, Philip and Sam, there are actually only 2 checkpoint that they will go to. And a complete matching is a one-to-one pairing, so you can't have 3 people on only 2 bases and create a one-to-one pairing. So the official way to write the answer is that a complete matching is not possible because, and the reason is because we've got 3 people, 3 from one of the sets of the bipartite graph, and those 3 happen to be Nicola, Philip and Sam. So Nicola, Philip and Sam can only match, and the word only is important, 2, 5 and 2. And whenever you've got that situation, 3 to 2 or 2 to 1 or 4 to 3 or whatever, if one's bigger than the other, you can't get a one-to-one pairing. Right, last one. So this is a root inspection. So we're going to start off with our box of results that we're always going to need. And, oops, I think I might have drawn those lines in the wrong place. I might put the totals here just because that's the smallest column. Okay, so our odd nodes are B and D and F and H. They're the odd nodes. So combinations are B with D, B with F, B with H, in which case the other pair would be these 2. So, unless I've gone wrong, the shortest connection between B and D could be BED or BAD, both of which are 21. B to F is BEF, which is 19. B to H is BEH, which is 23. F to H, the shortest, is via E, which is 20. H to D, the shortest, is via G, which is 20. And F to D, again via E, that's 18. So the totals are 41 even, and 39 and 51. So, part A, what's he doing? Joe is going to travel along each tunnel at least once, and he has to go back to where he started. Remember on each arc? Oh yes, he has to start and finish at A. So he's got to go back to where he started. So we need the smallest total. So we say the smallest is 41. So if we're going to choose the 41 repeat, then we need to repeat this and this. So that means that we're repeating the F to E and E to H, and then you could have either of these two. You could say BE and ED or BA and AD. So we're going to repeat F to E, E to H, B to E, and E to D. Although these two could be B to A and A to D, that's equally fine. Then we say what the total length is. Well, the total length is the original length plus the bit we're adding on, which is an extra 41, so that's 166, and it must say kilometres. So that's the first bit done. Oh, we need a root. So what have I got? I've got A to B to E to B. Oh, I'm repeating my EB there. He's repeated. And then, I don't know what I did. Then to C to F, what else am I repeating? E to H. I might put these other ones on so I know they're there. So I've got a repeat there on E to H. I'm going to change that. A repeat here on E to H. That's that one. A repeat on F to E. That's that one. I've already repeated B to E, and I've got a repeat on E to D as well. Like that. Okay. So you should be able to just zip around this, to be honest. I think I'll go down and up and back and right and down and right and that and that and that and that and that, and then back to A again. So one potential route that you could have is A, B, E, B, C, F, E, F, I, H, E, H, G, D, E, D, A. And so long as you've got the same number of letters as me, you're probably right. There are ways for the examiners to check. They count the number of letters, and they count, for example, how many B's you've got should be the right number of B's or the right number of H's. Okay, let's just shrink this down. and have a go at the part B. So part B can start and finish at different places. So you want to have a look, ignore this completely, have a look at these numbers and see which one the smallest is. Now the smallest is 18. So ideally, what we're going to do is we're just going to repeat F to E and E to D, and that's all. F to, what are we doing? F to E and E to D. Like that. They're the only ones we're going to repeat. Now that makes D even and it makes F even. So these two are now going to be even, which means that B and H remain odd. And the odd ones need to be where we start and finish. So we go through the same process. We say that the smallest is 18. So we're going to repeat, and it's not FD, it's FE and ED is what we're going to repeat, those two arcs. And now we say where we're going to start and end. So we're going to start and end at B and H. And the new total length that we walk would be the old total, which is 125, plus the 18 extra, 143 kilometres.